Some more functions to differentiate, and again we're going to keep using our different rules. This one again is going to use the product rule, so the derivative of sine 2x is 2 cos of 2x times the second function cos of 3x plus the first function times the derivative of cos 3x, which would be minus 3 sine 3x. So, and then we can just clean it up, put the minus there, and put our functions with our numbers in the front. Again, the product rule here, there's our first function and our second function. Derivative of x squared plus 4 is 2x times the tan 3x. And our first function times the derivative of tan 3x, which is 3 sec squared 3x. You can put the 3 out the front and clean it up there. This one here is going to use the chain rule because we've got a function to a power. So bring your power down, bracket stays the same, subtract 1 from the power, and then that's all multiplied by the derivative of what's inside the bracket. 3 cos x becomes minus 3 sin x. Cos x differentiates to minus sine, and sine differentiates to cos. So we can just leave it in that form. We don't need to simplify it any further. Derivative tan squared of a half x. Again, this is a chain rule because you could take the 2 there and put it all out and put the 2 in there because that's really what it looks like. Bring the power down, brackets stay the same, like tan to the power of 1 times the derivative of what's inside the bracket, so it gives you the half secant squared of half x. 2 times the half will cancel, and that will leave us as tan of a half x sec squared of a half x. Log of a function, derivative of a log function is the derivative of the function, so 3 plus tan x derives as sec squared x over the function itself. So we can leave it in that form. This one would be the chain rule because it's cos of 2x all the power of a half. The square root makes it the power of a half, so we bring the power down, subtract 1 from the power, the bracket hasn't changed, then we multiply by the derivative of the bracket, and the derivative of cos 2x is minus 2 sine 2x. You can just bring that out the front, you could leave it like that as well. The half and the 2 cancels though. And again, the derivative of cos x on sine x, we're using the quotient rule. So derivative of cos is minus sine over sine times sine, and then minus cosine times the derivative of sine, which is cos. And that would give us minus sine squared x minus cos squared x over the sine squared, which we could actually bring out the minus there and have sine squared x plus cos x. We can just clean this up a little bit. And over the sine squared x, and that actually will be 1 because sine squared x plus cos squared x is equal to 1, so we can clean it up to get minus 1 over sine squared x and leave it like that. And then again we can take this all up and make it equal to the cos of x minus sine x to the power of minus 1 and apply the product over the chain rule. Bring the power down, bracket stays the same, subtract 1 from the power, and multiply by the derivative of cos x, which is minus sine, and sine goes to cos. And then we can just rearrange it, because they can both become positive now, and we can leave it in that form. Again, we're just showing how we can apply all those different rules.